Hello, welcome to today's lead code solving session. Today's problem is 846 hand of straights. Let's read it out. Alice has some number of cards and she wants to rearrange the cards into groups so that each group size and consists of group size consecutive cards. Okay. uh, Groups so that each group size of size. Okay, so if it's like group size is 3, it's just like 1, 2, 3, 2, 3, 4. Okay. Given an integer array hand, where hand is the value of the value written on the card, and an integer group size return true if she can rearrange the cards or false otherwise. I see. How is this a medium problem? I mean, simple sorting, just sort it, and then once you sort, you start from the smallest card and like pair into groups of group size. Wondering, it's just consecutive cards. Does consecutive mean oh, okay. Just wondering if like 1, 3, 5 is also consecutive. This is the different difference is the same, right? Why am I confusing with synonyms of consecutive? Successive. Yeah, maybe I am. Yeah, I think I'm confusing with sequence. Let me just check the. Let's say return true, and let me have something like 2, 5, and 2 plus 3 is 5, and 5 plus 3 is 8. So, and a group size of 3. Let's see what this returns. Okay, this is expected to be false. So yeah, then in this case, it's an easy problem. If it's at consecutive, then I'll have to think. How would I have solved that? Probably some kind of TP, but yeah. What I'm gonna do is I'm just gonna like sort it and then pop from the end. Currently, we have cards which go to 10 power 9, so that's interesting. Let's do this. Yeah, this should like make it a bit faster, like weeding out all the bad ones. Bad. Yeah, then 0 on 0 is gonna be 0, isn't it? That's not smart. Mm, good. So this is equal to 1. Let's just return 2 here because I don't wanna get an error here. Maybe there's like a more elegant way of doing it because usually with lead code I don't like to write edge cases because they usually give the constraints in such a way that you don't need to write edge cases. But if you're watching my boring videos and then you feel like you have an improvement, please go ahead and comment. Mm, you don't need to put end here because we usually, we don't need to put for else. Uh, if you don't know for else loops, you can look for basically for else loops. But I don't need to do that because we're not breaking anything. Nope. Yeah. Interesting. Sorry. Uh, let's print and here. I see. Yeah. Okay. This makes sense. Yeah. Okay. This is not an easy question. Let me take that back. Mm. Okay, let's re-strategize. For every number that's the largest or the smallest, we take that. Then we look if there is a number which is like one less than that in the hand, in hand. Yeah, and then if that's that, we don't pretend points. You can use a dictionary here. Hmm. Yeah, basically what I'm gonna do is for e like from the largest number, I look for any smaller numbers. But the thing is, I'm kind of trying to make a decision on how to create that loop. So what I'm thinking of doing is using a counter again. Uh, use counter in yesterday's problem as well. So I'm going a little counter this week, and yeah, to do this to sort of um, just wondering if I need to do this. Right, let's see. It's not too bad. Just wondering if there's gonna be if this kind of solution can get to group size power, uh, hand into group size. I don't wanna get that. So probably won't because every time we find something in there, we're gonna take, uh, we're gonna decrease the length of like characters we are looking by group size because let's say we kind of remove them from counter, and then once we remove them from counter, we don't have them anymore. But on the other hand, yeah, I'm pretty sure this is gonna run though. Yeah, I think this should work. Yeah, and I think ideally this is gonna even work if the like card number. Interesting. Expected true. Because why not? Oh my god. I made the same logical error twice. Wow. Do this. Just wondering how much will this affect the complexity of the problem? Yeah, I'm getting a TLE. No, I didn't get a TLE. But it's obviously really bad. And performed decent memory wise. Yeah, I mean the last few solutions that I got, they all performed well memory wise, but they all look kind of bad runtime wise. Maybe that's my thing. One more solution I had in my mind while I came up with this is instead of a counter, I'll use the default dictionary of less, and I'll basically you'll see. Uh, and that's that, right? And again, we do this from the reverse. Basically, I for each number, I'm gonna take and keep a note of its index, right? This is gonna be 0, 1, 2 is gonna be, uh, yeah. Here, we're gonna have a dictionary with the left a key value of 1, but it's gonna have 0 and 1, and then we're gonna have a key value of 2, and we're gonna have, so it's gonna be a sorted, no, it's not sorted, but yeah, we're gonna have array of like a dictionary with list 2, and that's gonna have 2 and 2. No, sorry, it's gonna have 2 and 3, and then this at key 3 we're gonna have a list with 4 and 5. And what I'm gonna do is I'm gonna mark these indices with a negative character. So basically, once I mark something with uh, as negative, it means that I have already exhausted it while checking for the consecutive numbers. So you're basically, uh, let me write the edge case for first, maybe then we'll follow. Okay. I can make this negative, but it doesn't matter anymore. because we're traversing mm-hmm. Yes. Right, nice cordon on this box. Yeah, it should work, hopefully. Hmm. Mm-hmm. Oh, I don't make such mistakes. Yeah, because usually I put N and then minus one. Let's wait for a second so we don't get the message. Okay, I think this is gonna run a little better. 83 pass, wow, the last one has to be the screw job, huh? Really. Sorry? I did this. That's fine. This is not the current time file. Let's recap it up. Technology. isn't breaking for zero. Because negative zero is zero. Let's see. Just make it like in. Yeah, that happened because negative zero is zero. And it performed a little bit better. I think I tried twice and looked at other answers. Okay, they're using heap. Why are they using heap? Okay, basically we have a heap PQ of if it's if the initial iteration of PQ is empty, we add the number and one. Okay, we append I by one. Cool, we're moving on to the next index. Current and L we take PQ. If current plus I is not wait, outing. Right. Uh, I kind of get what it's doing, but not like totally. Probably gonna look at solution. I'm not gonna show the solutions on fewer because I don't know the copyrights, but cool. If that's all, I think that's all for today. Peace.